Dear students, greetings. This is Dr. T. Sendilmurugan, Associate Professor, Department of IT. In this video lecture, we are going to discuss about declaration of variables and we will discuss about arithmetic operators. Okay, so what are the operators are there? That operators and arithmetic operator we are going to discuss in brief. Okay. So this is week 1, lecture 3, classroom discussion topic 3. Okay, so third class we are going to discuss about declaration of variables and operators and expression. Under this title we are going to discuss about arithmetic operator and relational operator. These two operators we are going to discuss in this video lecture. Outcome of this video lecture: after completion of this lecture, students will be able to develop the C program using variables and arithmetic and relational operators. Okay, so we are going to discuss about variables, how to declare the variables, how to use the variables, and what are the arithmetic and relational operators. In C language, we have primary data types. Okay, data type means how we are declare the variable. Variable is which type. Okay, so data type means which type of data. That you just remember it. When we are declaring the variable, we must be mention the type of the data. So in integer, related to integer, we have 4 basic types: integer, character, and floating point types, as well as no return type, that is void. Okay. So in integer, we have signed integer, integer, short integer, long integer. Okay. Under the signed integer, unsigned integer is there. In signed integer, we can say int, short int, long int. That means short integer, long integer. These are based on the size. Okay. Here unsigned integer, unsigned short integer, unsigned long integer. So here unsigned if you are using means it will be used for both the direction, only positive numbers it will take. Okay, so integer it will take 2 bytes of memory. So whenever we will take, so nowadays the operating system allocate 4 bytes also. So previously it will take 2 bytes. So the integer values will occupy 2 bytes or 4 bytes in the memory. So character have 1 byte of memory. Okay, so character will occupy 1 byte of memory. So character also we can say character, signed character, unsigned character. Okay. So then apart from that, floating values. So which number we have, point numbers are there, no? That pointing numbers, precision numbers. We can mention using the precision points, that is considered the float values. So it may be classified into float, double, and long double. Okay. So here float it will take 4 bytes of memory and double it will take 8 bytes of memory. Okay. So long double it will take long values, more than double it will take long double. Okay. So void is no return type. It is not written any value, no return type. Okay. So these are the basic data types in C language. So initially, how we can say the types? When we are saying about the type, now we see basic types. That is integer type, floating point types. So normally arithmetic types are classified into integer type and floating type. Integer means the numbers. Okay. So normal we are using 101, 1000, 2500. So these are the integer values. Okay. So the integer value take 4 bytes, so maximum 4 bytes it will take. So 4 bytes means each byte have 8 bits. 4 into 8, 32. So 32 bits it will occupy. Okay, so 32 bits it will occupy in the memory. So how many space it will take? 2 power 32. So up to this value we can store there. So floating point it have again 4 bytes only. The same thing. So recently integer is taking 4 bytes. Floating already have 4 bytes only. So it is also used the 4 bytes. Enumerated types. What is enumerated types? So this is also arithmetic type, enumerator type also arithmetic type, but what they are used to define the variable that can only assign certain discrete values. Okay, so we can assign the value, discrete integer value throughout the program. Okay, so the same program it will be used in the throughout the program, that is enumerator type. The type void, already told, it is no return values. So that means no value is available for void data type. Wherever we don't want the data, there is we can use void. The last one is derived type. The user can derive the data types. Those are pointer types, array types, structure types, union types, and function types. So these all the types are defined by the user. So user defined data types are derived types. Okay, so we can say like that. So these we will discuss later. Okay, so now we are going to discuss about that. So this is integer value. So integer and float value, what is the size it will take and what is the range of the values. Okay, so you just see here character or signed character, it will take 8 bits. So 8 bit means 1 byte. Okay, so unsigned character also it will take 1 bytes. So 1 byte means what is that? 2 power 8. Okay, so 2 power 8 value it will take. But normally how the values will take means 2 power 8 to, so minus 2 power 8 to 2 power 8 minus 1, that side. Okay, so this is the value we will take the ranges. So normally 2 power 8 means 8 bits are there. Okay, so here what happened, both it is unsigned, no, so both the values it will be there. So 0 to 2 power 8. Okay, so that is the value here. 2 power 7 to 2 power 7 minus 1, here 0 to 2 power 8, only positive numbers. So same like that the values may be here. Okay, so 2 power 15 minus 2 power 15 to plus 2 power 15 minus 1, that is the value we will take here. Here directly we can take 0 to 2 power 16. Okay, 2 power 16 value is 65 536 actually. So the answer it will be minus 1 because 0 we are included, no, so that value we will take. Total values are 65 536. So signed short integer, unsigned short integer, both it will take 8 bits only. So it is compared with that short values we will take means it will occupy less memory. So again it will take it only 2 power 7. Okay. Then signed long integer. Long integer, whenever we are saying long, so it will be multiplied with 4. Okay. So 4 into 8, 32. So 32 bit it will take. The values are taken from 2 power 31 minus 31 to 2 power plus 31 minus 1. Okay. So here unsigned long integer, only positive direction. So that means 0 to 2 power 32. Okay. So this value minus 1. Up to this value we will take. So this is the float values. Float values we can use exponential values. We can represent using exponential values. Okay. So this value starting from 3.4e minus 38 into 3.4e plus 38. So that means this is also it will take 2 power 32 minus 1. Here double value it will take 64 bits like 8 bytes. Okay, so this is 8 bytes. So 8 into 8, 64 bytes. If in case we want to use more numbers means we will go for long double. Long double it will take 80 bits, that is 10 bytes. Okay. So 2 bytes are more compared with double values. These are the sizes and ranges of integer and float values. So here float values, how much decimal it will take. For example, I told float it will take 4 bytes. Okay, 4 bytes means 4 into 8, 32 bits. So 32 bits means it will take 2 power 32 addresses. Okay, so inside you can use this many addresses. Decimal places, how many decimal places it will take? 6 decimal places. Normally, if you are using float values means it will use 6 decimal points. So example, if you are declared float values means float A means what is the meaning of that? A, it will use some values. So example, some integer values like 10. Point. After point, how many decimal places it will take? 6 places. 0, 0, 0, 0, 0, 0. So this is for floating point, 6 decimal points. So in case if you are declared double, double means double A. So what is the A value? A value is 10 point. So 15 zeros will be there. Okay. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this many zeros will be there. In case long double means it is 10 bytes, it will occupy 19 decimal places. After the number, after the dot, there is 19 numbers will be there. Okay. So how we can use the keyword in the programming? So in case character is there, how we can use it? Okay. So here character means CHAR. Only we are using char. Unsigned character, unsigned should be there. For instead of character, CHAR only will be there. So signed character, signed will be there. Char, CHAR is there. Signed integer, wherever the integer is there, that we can represent int. Okay, signed int. Or we can simply use int also. Signed short integer. So we can use signed short full form. Then instead of integer, int we are using. Signed long integer. Okay, signed long integer or long integer directly we can use. Okay. So even if you are using only long also, it will consider as the long integer. Unsigned integer means again you can use only unsigned or unsigned int. This is also you can use. Unsigned short integer, so you can use unsigned short again integer instead of integer you can. So without integer also you can write unsigned short. Okay. So for floating point, we can use a float. For double precision floating point, we can use double. Extended double precision floating point, it is long double. Okay. So this is the words we are used, the keywords. These words we are used in the programming to declare the type of the data. So example, how we can write the integer. So you see here, these are the literals plus 111. So if it is integer type, so once we see the number itself, we can define what type of data we will use. Okay. So you will see here plus 111. This is integer number we know. Okay. Minus 222. This is also integer value. So for unsigned integer, when we are seeing that integer number end with u means that is unsigned integer. Okay. So if you are declared like this, if you are using this number, it is the type of unsigned integer. Okay. So that long integer, if you end up the number, if you are using L, capital L, it is considered a long integer. If they end up the number, if they are using UL, unsigned long integer. Okay, so just to see here, the number will be there, but we are using this type. So example key, floating points, 0 point. If it is there means that is if any number dot with. So the default floating value is double. Okay, so default value is double. If you want to declare as float means we can use F. Okay, if you are using F, then only it will consider as the float value. Otherwise, it will consider as a double value. 0, 0.0, 12.0, 1.234. So all these are, there is no mention of F. So we can, this is the point numbers. Simply we can say these are the double values. Okay. So it is float number means simply we can use F. If it is the long float, so we know that 1.23. It is normal number. This number is represented the double values. So if it is the long double means you can use capital L end of the precision point. These floating numbers. So that will be represented as a long double. Okay. So now how we can declare the variables? So this is the declaration of variable. First we have to write data type. Then variable names. Okay. So variable names, end of the variable names, you have to use a semicolon in the program. The variable names also separated by the comma. So here I given names because you can separate it by comma. You can give more values separated by comma. Okay. So how we can type integer? Already data type now we are discussed. Integer value int. Okay. So int, for example, 234. This is integer value. For that we can declare the variable. So variable means we will use some variable. For that we can assign the value. So how we can declare? Data type first, then variable name. So I will take any variable name. Integer x. I declare like this. Okay. So this is the variable declaration. Int type I declared. So here short integer also you can use short in front of that. Unsigned short integer means unsigned you can use. Like that you can use the word for data type, and variable names you can like this. So I told several variables now, x, y, z. So how we can use this variable? Already we discussed some rules. Okay. So it may be combinations of alphabets. Okay. So alphabets means A to Z. Okay. So capital A to Z and number digits 0 to 9 and underscore. So these combination you can write the variable name. But only condition is it is starting with only underscore or characters. Okay, not digits. So example A1 we can write it. A we can write it. A1 2 we can write it. A to B we can write it. Okay. So underscore A we can write. So only condition is 1A. If you are writing it, it is wrong. Okay. So it should not start with numbers. That is the declaration of variable conditions. Okay. This is the variable declaration. So variable you can give like this combinations. Then they declare the type. For example, float numbers. Float is a data type. Then you can give any value F1. Okay. First condition is should not be a keyword. First one should not be a keyword. We know that C language have 32 keywords. Don't use the keywords here as a variable. And second one, the combinations of alphabetical characters and digits and underscore you can use. But only condition is it should not start with the digits. Okay. So float, then type double x. Okay, so you can give any variable name here as per your want. Okay, as per your requirements you can declare. So character. So how we can declare the character? Char, then any value CHI will use. So instead of that you can declare that character A1 also you can declare, no problem. This is should follow the rules only. So this is the variable declaration. How to initialize the value? So while declaring the value, we can give some values for the variable. Initialize the value, not variable. So you just remind it what is value, what is variable. Okay. So these are the variables I told. This is the value I told. Okay. So while I am declaring itself, I will give the value into x equal to 5. This is the integer number I will give. Okay. Comma y equal to 8 semicolon. I already told variable we have to assign the value. This equal symbol is not equal symbol, actually it is for assignment operator. So what it will do, it will assign the value from right side value to left side variable. So now we are assigning 5 into x. Okay, so 8 into y. So separated by the comma we are written. Each statement in the programming we can ending with semicolon, don't forget it. How you can declare again? Float. Example F1 equal to. So we know that point values is 5.82. Okay, like that we can declare. Clear? So this is initialization of the value. Character. So in case how you can write the character? Character A1 equal to. So within single quotes you have to assign the value. For character you can use single quotes. So example, my name I want to print first yes. So I declare A1 equal to yes, comma A2 equal to E. Like that, I can write how many character you want, you will type it. Okay. So ending with semicolon. This is the variable declaration. Okay. In variable declaration, we can define the type also. Okay. So the C support feature of type definition. We can define the type also. Okay. That allows user to define the identifier. We can define which identifier we can use for the type. So in case you see the example, then easily you can identify. User defined data type identifier, and later we will discuss declare the variables. In general form, how we can type def should be there. We are defining the type def is a keyword we can use. Then which type we will use, that we will give, then identifier. So example you see here, type def int equal to units. So wherever I use the units, that will be considered as an integer. So that we are defining it. Okay. So I don't want to use integers. Okay. So instead of that, I am using units. Wherever I am using units, that is the integer value. Wherever I am using marks, that will be the float values. Okay. So normally how we can write data type, variable name we are using. But in type def, once we are defined the type, then we can use directly instead of int units, batch 1, batch 2, marks, name. So like some float value will take. Okay. So this is for type def of. We have some 4 storage classes. So what I said, when we are declared the variable, the operating system will allocate the memory. So how much memory it will allocate based on the type. Already we discussed integer means 2 bytes, float means 4 bytes, double means 8 bytes, like that. So once we are declared the variable int x, if I declared means the operating system will allocate 4 byte of memory for this x. Okay, it will allocate the memory and store the variable name is x. So if in case we want to assign any value, so x equal to 5 means 5 will be stored here. Okay. So how we can represent this value? We can represent this as ampersand x. That means address of x. The ampersand symbol used for address. Address means where we are stored the value. The operating system knows where it is stored, but we don't know. So simply we can inform the operating system that address of x, where the value wants to store. So address of x. Ampersand symbol used for address. So while declaring the variable, it is the storage classes. Okay, auto, register, static, extend. These 4 storage classes are there in the C language. First, auto. What is auto? Local variables known only to the function in which it is declared. So normally we are declared no int x. This is the local variable declaration because we will declare this variable inside the function. If you are declared this variable means, what is the meaning of that? It is default. So in front of that value, auto it is there. Even you are writing or not writing, it will consider as the auto. This is the auto storage class. Static storage class. What is a static storage class? Local variable which exists and retain its value even after the control is transferred to the calling function. So that means a constant. Okay. So if you are declared the static value means the value will not change throughout the program. So is static int x equal to 10. If I design means wherever I am using x, the values are 10. So we can do that. So even constant keyword also we can use. Even macro also we can use has defined. We are using no. That also you can use for defining the value. Next one extend. So what is extend? Extend means global variable known to the all function in the file. So wherever we are declared the global variables, what I said global variables, the variable declared outside of the function, the variable can use all the function in the C program throughout the program. Okay. So there that is considered the extend storage class. Register storage class. What is register storage class? Local variable which is stored in the registered. Okay. So temporary purpose it will store in the register instead of RAM. RAM it will store in the register value. Okay. So now how we are assigning the values? I told you no. So variable name should be there, equal to constant value should be there. So even variable declaration also we can assign the value. After declare the variable also we can assign the values. Okay. So if example, what they are saying is int initial value, initial underscore value. I declare this value. So normally I can declare here also in the initial value equal to 0. This is also same. Or after declaration, I can write it in the separate line. So this line will be there. Initial value, initial underscore value equal to 0. We are assigning the value. So I already told this is the floating values, this is the integer numbers, this is a character. So how we can declare? We can write it in the different lines as well as even same line also we can write, but separated with semicolon. If semicolon you are used means that line is over, then it will consider the next line. Okay. So this is the initialization I told how we are initialize the value. So you can assign the values like this also. The variable, so in case you are declared int p comma q comma s. Okay. So initially you are not assigned value. So you can assign the values like this also. How it will assign? I already told this is assignment operator. First 0 will be assigned to s, then s value assigned to q, then q value assigned to p. So what is the value? S value equal to 0, no? So all the variables getting zeros only. Here you see. So normally value we are assigning, okay. Here variable is there. So where we are using the variable? For example, the max value it will take and assign to a z value assigned to y, and y value assigned to x. Condition okay. But what we have to do? The maximum value should be used in the define processor. Where we have to write as define max equal to 10. So not equal to max space 10. If you are defining the value, then we can use this statement. Otherwise, this statement is wrong. Okay. Before that, max have some values. Okay. So now we are going to discuss about the operators. In C language, we have some operators to perform some operations. Okay. So built-in operators are there. In C language, operator means that is symbol. Okay. So operator means that symbol that tells the computer to perform certain mathematical or logical manipulations. So what we are going to do using the operator? Operator means simply the symbol, mathematical symbol. So we know that plus, minus, multiplication, division. For that we are using. For addition we know that plus. For subtraction we are using minus. For multiplication we are using. Normally we are using x, but in computer we are using asterisk. Division we can use slash symbol. Okay. So there modulo is there, modulo operation is there. For modulo we can use percentage symbol. So these are the operators. Okay, this operator will perform some mathematical or logical functions. So that operators can classify like 8 operators in C language: arithmetic operator, relational operator, logical operators, assignment operator, increment and decrement operator, conditional operator, bitwise operator, special operators. So what are the arithmetic operators? Which operators helps to do the arithmetic operation? Those operators are arithmetic operations. So these 5 operators are arithmetic operators. What is the relational operators? Relational means it will check the relation. It is greater than or less than or greater than or equal to, less than or equal to, or equal to, or not equal to. So these are the relational operators. What are the logical operators? Logical operation we know that normally. Okay, and, logical or, logical not. So what are the symbol we are used for and? So logical means both. 2 ampersand symbol we will use, or means 2 parallelogram symbol we will use, not means exclamatory symbol we can use. Okay, so these are the logical operators. Assignment operators. What are the assignment operators? It is assigning the value to the variable. So equal symbol, assignment operator, then plus equal to, minus equal to, multiplication equal to, division equal to. So these are the assignment operator. What is plus equal to? If example A plus equal to B, if it is there means A equal to A plus B. So this is the meaning it will represent. Okay. So first add the B value with A, then it will assign to A. These are the assignment operators. Increment and decrement operators. So increment means increment by 1 plus. Okay. These are the increment operator. Minus means that is decrement operator. There is post increment, pre increment is there, pre decrement, post increment is there, that we will discuss later. Conditional operators. Again, we have to check the conditional operator. Conditional operator or ternary operator. We have to check the condition, question mark, colon. So this is the ternary operator or the conditional operator. Next one, bitwise operator. Bitwise means we can perform the operation using bits. So each and every binary value we can consider the bits. Zeros and ones normally we can say that's the bits. 0 is the bit, 1 is the bit, like that we can say. So we can perform bitwise operation, that is considered the bitwise operators. Bitwise AND we can use AND symbol. Bitwise OR we can use only parallel symbol. And bitwise NOT we can use this symbol, bitwise NOT. Okay. And bitwise XOR we can use apostrophe, this arrow mark. So these are bitwise XOR operator. Special operators we are using comma, parenthesis, brackets, ampersand symbol. So these are the operators we are used. Okay, comma is separation of variables, and the semicolon is used for the ending of the statements. Ampersand symbols, parenthesis, square brackets. So these are the special operators used in the C program. Okay, so now we are going to discuss about arithmetic operators. So we know that these are the arithmetic operators. So what are the arithmetic operators? Addition, subtraction, multiplication, division, modulus. These 5 are arithmetic operations. Okay. So these operate on any built-in data types. So built-in data types we will use. So now integer arithmetic. What is integer arithmetic? When the both operands in a single arithmetic expression such as a plus b are the integers, the expression is called integer expression. So a equal to 10, b equal to 15. So I will perform a plus b. So this expression is considered as an integer expression. Okay, so that is considered as an integer expression. This operation will perform now. This operator is considered as an arithmetic operator, integer arithmetic operator. Okay, so integer arithmetic always yield the integer values. Largest integer value depends on the machine. Okay, so already we told it is 2 bytes or 4 bytes, the machine dependent. If it is 4 bytes means the largest value may be changed. So how the expressions are there? The sample for arithmetic operations. You just consider here. Okay, so I am assigning 2 values. So normally how we can perform the mathematical operations? A equal to 14, B equal to 4. So we can perform this arithmetic operation. A minus B equal to 14 minus 4, 10. A plus B equal to 14 plus 4, 18. So 14 into 4, 56. 14 by B, that is 14 by 4, 3. It will take only decimal part. Wherever we are using division operation, it will take decimal part. Wherever we are using percentage symbol, that is modulus value, that will take only remainder value. Okay, so only remember that we have to remember that modulo division. Whenever we are using modulo division, we have to use a signed values are there. No, if the first value, first operand sign, whatever the sign is there for the first operand, that we will be used in the result. Okay, 14 by 3. So it's a modulus value. We will get 2. Okay, so how we will get 14 modulus 2? So 4 into 3, 12. The remainder is 2. So 2. The first operand value is minus. So we are using minus. So here also minus. Simply we can use minus. Then here we are using plus. Even we are using second operand minus also. We can use first operand value. So plus 2 only. Okay. Just remind it. Next one is arithmetic operation, real arithmetic values. Okay, so integer arithmetic is seen. This is the real arithmetic operators. Real means that floating values. Okay, so we are using float values. Example, there is x equal to 6 by 7. Okay, 6.0, 7.0. The answer may be 0.6 digit it will print. Okay, this is float values now. So it will use 6 precision points. Here 1 by 3. So normally we are using 0.33, but float values it will print. So here using that negative symbol, so negative symbol it will becomes for that. The operator percentage cannot be used with real operands. So we don't use modulo operation in the real values. Only integer value we can perform the modulo division. Okay. In float values we are unable to do. Mixed mode arithmetic, that means both integer and float will be there, no? That will be considered the mixed mode arithmetic operation. So example, yeah, the value 15 and 10.0, if you are divided it, the answer is 1.5. We have declared the variable 1 integer means then it is not print 1.5, it will take only 1. That 1 is the answer. Okay. When you are using the mixed arithmetic, it will use the type. Next we are going to discuss about relational operators. What is a relational operator? In this diagram the table is given. Sorry. These are the relational operators. Okay. Less than or equal to, greater than or equal to, not equal to. This we can check the relations. So example, 10 less than or less than 20, it is true or false, we are checking. It is true. Okay, when we are using 20 less than 10, it is false. Okay, so it will check true or false operations. It is 1 true and 0 is relation is false. Okay. So see here, it's a complement. So example, we are using 6 relational operators. Each one is complement of another operator. So how we can write it? Greater than is complement of less than or equal to. Okay. So less than symbol is complement of greater than or equal to. So example, how we can say that? For example, 5 is there. 5 greater than 3. So this statement, how we can write it? 3 less than or equal to 5. We can check this condition also. Okay, so which condition is true or not? So this is the complement of the values. So example, expression involving the not and the less than operator using the complements of shown in the figure. Whenever we are using not operator, that is complement operator. Okay, how we can write it? So it is not means it is false statement. Okay, so not means should be, we have to find that value, that opposite value we will take actual value. But how we can find it? If you are using that, we can use the complement value. Okay, so this condition we will check. Instead of not operation, we can perform these operations. Okay, so now you just see that in modulo division, what is the answer for the following? You just find it. What is the answer for this? I will give 10 seconds time. Okay, our time is over. See the answer. So here we are using plus symbol. So directly we can write plus symbol only. So no need to mention any sign. Here plus value. So 72 by 7. So 10 value. 10 is the answer. Sorry, 2 is the answer. Okay. So remainder we will write it no. So 2 is the answer. So no need to mention any values. Here 80 by 6. So what is the value? Then the answer will be right using the minus, because first operand variable is minus, so we must be use minus. So again it will take 2. Okay. So 78 it will come, remainder 2. Here So second operator will have the minus, but we don't consider about it. Only the first operator value we can use, that is plus value. So remainder 3. So plus 3 answer. Okay. Here also first operand is minus, so minus 3 will take. These are the answer for this question. If you are answered correct, you will follow the video. Otherwise, you will go before and watch the video again. Thank you. Thank you. We are in the end of the slides. So we have to revisit the outcome. So you know that having completed the discussion on declaration of variables, arithmetic and relational operator in C, now students should be able to, you are the student, you are able to develop the C program using variables and arithmetic and relational operators. Okay, you try this program, develop the C program to print address using different data types. So you have to print your address using different types like character, integer, float, double. This type you can use in your address, then you can print it. Okay. So where you have to use character, names you can use character. Okay, integer, maybe your street number you can use integer. Float values may be used like street number, finding numbers, otherwise you can use double like phone number or pin number. You can use that values. Okay. So then develop the C program to perform arithmetic operations. So we know that arithmetic and relational operation we check. We can write the program for addition. So we can develop the calculator example. Okay, the calculator will perform addition operation, subtraction operation, multiplication operation, division operation, modulus operation with the 2 operands. Okay, you can try it. So for further extensions, you just refer the textbook, chapter 4, operator and expression. And also you can visit with weekly tutorials. Okay. Thank you very much for watching this video. We will discuss next topic in next video. Thank you very much.